Okay, the problem statement is count the number of special character. Part one. So what is a special character? Like one string is given, string that's word is given. A letter is called special if it is both in lowercase and uppercase in the word. So that is special character. So special character. So what is the length of the word is 1 to 50 only. Very basic. So let's see a couple of examples. Let's say my word is A, B, C, D, A, E, and this is, let's say this is my word. Okay, this is my word. So what are the special characters? Special character is what? See here, A is here appearing in lowercase as well as uppercase. Correct. You can see B is appearing in the uppercase but not appear in the lowercase. Similarly, C appears here in the lowercase but not appearing in the uppercase. So, but D here is appearing in the lowercase and also appearing in the uppercase. So here A and D are the special characters. Okay, I've written the number of the special character letters. Okay, and but see here, A is appearing twice. So what is the number? Is it 2? No, A itself is a letter. That is a special letter. It doesn't matter how many times A appear in lower form and uppercase. Only if it is only once, is the occurrence like only one occurrence of lowercase and one occurrence of uppercase present, at least, then it's a special character. No matter of how many times it's appearing in our string. Okay, very simple basic problem. How could we take it? So what we could do, we can take an extra array, one array to store the like number of occurrences of this lower digit. So if it is a lower digit, I will store the occurrence. If it is higher digit, I will store the occurrence. So this is how we can store the occurrence. Correct. So and after that, you can see uh, if the occurrence is more than one, then it is fine. Otherwise, it is. It does not appear. Let me show you how could we do that. So let's take this example. Okay, so I need to let's say I need a function. What is the name? Let's say count the special character. Okay, what is given? Word is given. That's all. So what could we need? We need length of the word. So n equals to word dot length. Okay, so word dot length, that is the length of the word. Now what could we do? This one. So we can just iterate one by one and check whether what is the count of it. So I am storing the count. I'm storing the count of, if it is small lower, I will storing the count in the lower case. If it is higher, I'm storing the count in the higher case, higher. So how many letters could be the length? Our English, it is an English letter, right? So English letter have only 26 alphabets. So we need a space of 26. So let me create one array and name as Luar. This Luar is nothing but an array of 26. Array of 26. Okay, length 26. And initializing everything is 0. That means nothing is appeared. Similarly, I am doing for upper as well. So for upper, also it is array of 26. Okay, that is the case. Now I will iterate each and every character of this word. So for each and every character, so character in this word, I am iterating each and every character in this word. I have to check if it is in lower, if the character is lower, then I'll so what do I add? I will add inside the lower array, right? Okay, so I'll add in the lower array. So just simple add. Now how could I add? So I need to find the, let's see, I have to add where. If it is a, then let's say A, B, C, D is present, right? So A, B, C, D, E. C, D, and E. So it is array 0, 1, 2, 3, 4. I have to add the, if it is appearing as a, I have to add the zeroth place. How could I find like it is a zeroth place? So we know the ASCII of A. ASCII of small a is 97. Okay. ASCII of small a is 97. So what could we do? If we and ASCII of B is what 98. So what if I am taking the character ASCII and minus ASCII of A, ASCII value of A? If I do that, then 98 is ASCII value of B and 97 is ASCII value A, then it will be placed in the correct place at the one place, correct? But how could I, for A is will be 97 and minus ASCII of A is itself 97, so it is 0. So I can add into the in the correct position, right? So that we could do. So what I have to do, we have to simply have to find the ASCII value of that, and each function has its own method. Find the ASCII value. So I'm adding a generic case. Generic means if lower of which value, ASCII of character minus ASCII of A. This is how we can find. So class equals to 1, class equals to 1, correct? So increase the character. So what will be my lower array in this case? So let's say create the lower here. So it will be A, B, C, D, E. Just by 0, 1, 2, 3, 4. Earlier it is 0, 0, 0, 0, 0, and upper will be initially also 0, 0, all are 0. Nothing but A, B, C, D, and E. Okay. And if it is not the case, then I will do in the same thing in the else for the uppercase. But here instead of lower, I have to write upper, and instead of small a, I will write capital A. Okay. So in the upper, I am writing the capital A. Correct? Hope you understand. So let's see what will be my output after updating. So first I will see it is 1. So it is nothing but a small array. Small array, so I have to update this one as 1. Okay. So this is update as 1. Then I am coming in here. B is capital B. So I'll update in the uppercase. So it will be updated at 1 here. Then C, smaller c. Then it will update in the smaller c. Smaller c. Then it is D, smaller d, so it will be updated in the smaller d. D. Then it is a E, correct? Smaller e, so it will, sorry, after that it is capital A, sorry, it is capital A. So capital A will update the capital A. Okay, fine. Then it is smaller e, so it will update the smaller e here. Then it will update capital D. So capital D will update in this place, capital D, not here. Will update capital D. Okay. Then smaller a. Smaller a also it will update to 2. Update to second place. It will become 2. Then capital A also. Then capital A it will update capital 2. Now what I have to check. Now I can. What are the places like what could be special character? If both have appeared, more than once. If both have appeared, so I will iterate through each and every index this to this. Yes, I'm storing to the count. I have to iterate and store into the count. So iterate and check if both are greater than my 1. If it is both lower and upper place, say in the same image is greater than 1, that means for same character it is appearing in lower and upper both cases. So that will be the case. So here if I see it will be the two cases. Here it will be only one cases, not the both. Here it will only one cases, not the both. But here it is the both cases. So A and D. E will be only one case, so it will not count. So that's it. I am writing on case. Let's say answer equals to 0, and another loop for upper loop ends here. For I equals to 0, I less how many times? 26, because I know there are 26 sets that are there only. So this is the case. If lower of I is greater than 0 and upper of I also greater than 0, I also greater than 0. Then I have to do what? Count plus plus, answer plus plus. What is my answer? Answer plus plus. And at the end, I will simply return the answer. I will simply return answer. Simple logic, return answer. Okay. What will be the time complexity here? Here will be for each what I am iterating. It is big O of n, nothing but big O of n, and inside everything is big O of 1, everything, and here also big O of n, big O of n. So time complexity is nothing but big O of n, size of the game. Space complexity, how many things I have to? I need 26, like I needing 26 length of array 2 times. So 26 into 2, 25. So 52 comes as it's apart from this thing. Apart, I'm ignoring this one. I'm just saying about this case. These two array I'm needing. So it is nearly big of 52. That is nothing but big of 1, constant space. So it is big of 1. So here, this is a simple, easy solution. Okay. So can we optimize further? Can we optimize further? Optimize further, like that thing is I need this kind of iteration. This iteration I need. But can I optimize in the optimize in the term of space? Can we optimize? Can I don't allocate any extra space and do it? Can we do it? Let's see. For to optimize it, we need to learn about bit manipulation. We have to do some bit algorithm. Not algorithm, just bit manipulation technique, you can say. So for an example, I am giving a normal basic cases. As you, our alphabet only contain A, B, C, D, and E. These 5 characters. So these 5 characters, our uh, our answer stores. Now, if I want to like you all know bits are nothing but 1010, like binary systems in terms of that. So if I represent this thing in a bit format. So bit we like when we write the bit will traverse from left to right. So let's say this bit, if 5, so 5 for our alphabet, I told you our alphabet is 5 length. So using the 5 bit we can say like bit is now, let's say it is a bit is 0000. If my bit is set, if my bit is like this is called unset case. If everything is 0, this is called unset. Any bit position, it is, if a bit is itself 0 point, it's right now 0, then it is called unset. If it is 1, then it is called set bit. So to find out whether my bit is set or unset, kind of that. So what could we do? We could let's set the bit, like if our case, what was the case, what was our example? This is our example. If we take this example, see here, let's do one by one. First is A. So I set bit 0 to A 1. So it is set. Okay, this is set. Now B is capital. Okay, B is capital. So again I will take two case. First one is 000 is above 1 is for lower, capital is small. Sorry, first one is smaller, below one is for what is called like uppercase. This is set. Okay, so first one this and this one is set. Now next one is small c. Now small c needs to be set. So I'm setting the bit, means this is present. Then capital D, sorry, small d also needs to be set. This is need to be set. Then what? Capital A. Then capital A need to be set. Okay. Then again, then what? Capital A done. Small e need to be set. Okay. Then capital D. Then capital D needs to be set. Okay. Then small a again. Okay. The small a, it is already set. So if I set a bit and again set it, doesn't matter, it will becomes 1. Then capital A also. And capital A also, like it is already set and I am setting it again, so it will not matter. Now I can again compare, if bit is set, then I can take, and if bit is not set, I will not take. So how could we find it out? Like now, one I'm saying one by one concept. So the thing, it when I told you like this case A is already set, I am setting bit again. So when it is not set and I am setting it back. So how could we achieve that? So current bit, let's say current bit is current bit is zero. Current bit is zero. Okay. So if I have to be set, then what could we do? Like if it is unset and I make an operation so that it becomes set. So I can do OR operation with one. That means 0 or 1, you all know. Or in our case, if anything is in 2 bit, if anything is 1, then it is becomes set. 0 or 1, it becomes 1. So current bit is 1, and I again if I do another OR operation, that will also, it will not update. Correct, it will not update. So that's why whenever we are going to add it into the respective bit position, we will simply apply the OR operation. So one was, for an example, let's say this one A B C. Okay, and my string is B. Okay, so earlier it was 0 0 0. I will get 1. I will get OR operation in this one, and this 0 becomes 1. So again I will get a, then again put a OR operation with a 1. So then it becomes only 1. It will not update. Then I got B. This 0, I apply OR operation in this place and it becomes 1. So this is the easiest thing I could know. So this is the OR operation, and at the end, this is the thing. So what can I say? Like in my string, is A, B is set and C is not present. So you can see C is not present here. This is how we can do it. Correct? Okay. So this is how we can do the set operation. Now we have to find it out what is the common operation. So for common, what do we actually need? For common, this is the lower, and this is the upper, right? So we need what? We need what is the common, what is present in both cases. How could I achieve? See here, if both are ones, that times I need only count that thing. If anything is zero, we no need that. So I need one operation so that if anything is zero, that will not count or that will not reflect in our case. So what could be the best operation here? Bit manipulation technique. It will be the AND operation. In the AND operation, if both my bit are one, then only it produces me one. Otherwise, it produces zero. So if I do this entire thing and this entire thing and operation, okay. If I do and operation, what will happen? One becomes one, it becomes zero, it becomes zero, it becomes one, and it becomes zero. And what are the number it has produced? I can directly count number of ones. Bit count is function could be there and count number of one. So it will return what is number of one, that is 2. So that is my answer. Simple as that. As simple as that. Understand how could we get this thing? Okay, so let's now see how could we add in the respective position. So how, like, my initially every bit was what, 0 0 0 0 0. So how could I know, like, for A I have to one here, for B, for D I have to add one here, for E I have to one here, for B I have to one add, like, do the OR operation here. How could I know? So here comes one fantastic technique from left side right side. So instead of writing A B C D like here, we can simply write in reverse case, like A will point here, B point here, C point here, D point here, and E point here. We can simply write this thing. And our lower variable is nothing but 0. I will initialize. So what is the bit representation of 0? Bit representation of 0 is nothing but 0 0 0, 32 bit, 16 bit, doesn't matter. Bit representation is 0. Okay, so everything is 0. My lower is 0. Now I will do what? I got A. So if I got A, so this is the lower, and this is, I am denoting this one as upper. Okay, this is for upper. Capital E, capital B, D, capital C, capital B, and capital A. Okay, so upper is also, initially upper is 0. So this is the bit representation. Okay, so how could I know, like, which bit I need to set? So I got what? First one, I got A. So which bit I need to set? This bit. What is the position? You can see 0th position, right? Okay, so if I do 1, what is the binary representation of 1? It is nothing but 0 0 0, lots of 0, and at the end it is 1. So if I do or operation with these two things, that means binary representation I'm writing in the 5 bits because I am taking only 5 bits example. So right now lower is what? Lower is 0 0 0 0 0, and I got what? I got A, right? A is nothing but I have to set this bit. So I need 1 here and everything is 0. Okay. And if I do the OR operation, that now bits becomes, this becomes my bit, correct? OR operation, correct? Hope you are getting it. Okay. So how could I get A? How could I? So it will be the initial position. How could I know it's the initial position? I will tell you in the next example. Next case is B, capital B. Capital B means my upper is what? Upper is initially 0 0 0 0 and 0, and upper bit, if I have to add in the B position is nothing but this position. This is my B, A B C D E. So this is I have to add. So how I have to add in this place, correct? This is how I have to add. So how could I shift 1 to here? How could I shift 1 here? In the case of A, it should stay here, and shift case it should stay here. How is it possible? See here, if you know the left shift right shift operator. So this is nothing but 1. If I do left shift, sorry, left shift of 2, it becomes, so earlier 1 means this 0 0 0 0 1. I'm only taking 5 pieces, so you can, here is multi 32 bits is 30, 32, like total 32 zeros are there. So if I do right shift, then it becomes 0 0, it shift 2 times. So 1 2, it shift 2 times and becomes here. Okay. For B case, what, how many times I need to shift? I need to shift 1 time, so I can write B equals to 1. So for B I can shift this many times. For A, how many times I can shift? For A, how many times? It is 0 plus, no need to shift. So it is nothing but 0. Okay, hope you get it. Now how could you find this 1 and 0? How could you get the 1 and 0? How do I know, like for D how many shifts will require? D is nothing but, this is A B C D, fourth shift, so I need fourth shift. So actually not fourth shift, I need 3 shift. For B, I need 1 shift. For C, I need 2 shift. For D, I need 3 shift. How could I know it is a 3 shift I needed? How could I get it? So think of here. Again, ASCII comes in the picture. What is the ASCII value of D? What is the ASCII value of D? It will be 90, I guess 100, kind of like. Small ASCII value of D is 100. ASCII of D. And if I subtract with ASCII of A, if I subtract with ASCII of A, ASCII of A, ASCII of A. If I subtract this, then 100 minus 97, what will be the shift? 1. For A case, this is the A, this is A, this is B, and this is D, okay. So for A case, if I do ASCII of A, and again minus ASCII of A, what will be the value? 0. And B, it will be again like ASCII of A, sorry, B, and minus ASCII of that. So what is the difference of ASCII difference? I can lifts it that many times, and it will help. Got it? So this is what we could do. I will give you a dry run after that. Let's write the pseudocode first. Take our example, what we have taken. This is our example. Let's say our function find or count, whatever there was, count, I guess, count word is given, correct? Word is given. So what I need, one variable. I need two things, lower and two arrays. Right now we need only two variables, lower equals to 0 and upper equals to 0. And then what I need for each character, again, for each character in this word. What I am doing here, I am checking if if my character is lower, then I have to add in the lower variable, otherwise I have to add in the higher variable. So is lower. If character is lower, then what I will do? I will doing the lower of I want, or this is the or symbol, or equals to, or you can write for simplicity, you don't need to shorthand. This is shorthand, that plus equals to minus equals to kind of thing. Lower equals to lower, or that our ASCII left shift of what is the ASCII value? ASCII of character minus ASCII of A. Minus equals to ASCII of character minus ASCII of A. This will I'll do simple, and else just opposite to the lower, nothing but upper. So upper equals to upper or 1 ASCII of character minus ASCII of capital A. Earlier it was small a, it is capital A. Okay, and at the end, the for loops end, so I need the combination, like combination of like what is the case. So I'll do what? So I have to find the common, which are the common. So common I want to find nothing but lower and upper. This is the bit end, bitwise end, upper, and in the end return, what I will return? Return common bit, number of bit is set in the common dot bit count. If there is function bit count, there will be obviously there will be some function. Use that function according to a language. This is the case. So let's give you a diagram. Okay. So lower. Okay. So lower is nothing but zero earlier. Zero, and zero means what? Zero, 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 zero. I am taking five, like A B C D is there. So it will be extend to the 26 letters, 26 bits, and upper will be zero, zero, zero. Initially it is this. Okay. First what we got? I got I got A, right? First what do we got? First we got A. Okay, this A. So what is the, okay, it is a lower. So I will do in the lower transformation. Lower I will do bit shift ASCII of A minus A. What will be the 0? So then what is the meaning of that? It is the meaning of 1, right shift of 0. So it becomes this. It becomes what? It will produce this one, 0, 0, 0, 0, and 1. This is my bit. So after that I am doing OR with the previous one. So it becomes 1, then 0, 0, 0, and 0. This is the OR operation. So this is my next lower. Okay, lower update to this. So I am updating to lower that with that value. Okay, so this is how we can do. The next step is what? Next step is B. The next one is this B1, this B. So what is the B? B is nothing but upper. So it will come to in this place, it will come in this place, and then it will show the upper and ASCII of that. Okay. So notice that I'm doing one ASCII, whatever is the ASCII is there, ASCII of B, capital B minus ASCII of A. What is the difference between A and B? It will be 1. This is 1. So 1 right left shift. That means 0, 0, 0, then 1, and then 0. 1 left shift. Okay. So 1 left shift. So what will, and after that I'm doing OR operation. So it becomes 0, 0, 0, 1, and 0. This will be a new case, correct? So I'll update this one. Like upper will be updated by this one as well. Fine, fine then. So after that, next one is C. Next one is C. So C in the case, C will come here and C will do come here and C will come in this place. SQ of C minus SQ of A, what is the difference will be 2. So what will be the case? So 1 left shift of 2 and it will become 0, 0, 1, 0, 0. What will be the OR? 0, 0, 1, 0, 1. This will be my OR, correct? So I'll update this 0 by 1, this 0 by 1. Okay. Next case, next one is D. So only it will be what? D minus SQ of D, that is nothing but 3. So that is the 3. So what I will do? I will do 1 left shift of 3. It becomes 0, 1, 0, 0 and 0. What will be the OR? 0, 1, 1, 0 and 1. This is my case. This will be the case. So it becomes my told you what? 0, 1, 1 and 0, 1. This is the case. Next character is capital A. Capital A. Capital A will come in the uppercase. Upper of capital A minus capital A. Nothing but what will be 0. So it will be 1 left shift of 0. Okay. So what it becomes? 0, 0, 0, 0 and 1. What it becomes? 0, 0, 0, 1 and 1. This one and this one. This is the case. So what is the case? So it will update to 0, 0, 0, 1 and 1. Okay, fine. Hope you are getting it. So after that, again small e. Small e means e minus a. It is nothing but 5. So what is the case? 1 capital left shift of 5. That means 1, 0, 0, 0, 0. It becomes 1, 1, 1, 0 and 1. It becomes this, right? So it becomes this one. Then capital D, it will come in this upper D minus capital A, nothing but 3. So 1 left shift of 3, it becomes 0, 0, 1, 0, 0. This will be this. So, sorry, third left shift, right? So 1, third left shift of 3, so 0, 1, 0, 0, 0. Third left shift means this one. 1, third left shift, so 3. 3 plus it will, so earlier it was 0, 0, 0, 1. 0, 1, it will 1, 2 and 3. 1 will be here. That's why 0, 0, 0. If I do the OR with that, it becomes this zeroth place. This zeroth place will becomes 1. Correct? Okay. Now let's see. Now two cases. A is appearing again. Small a comes here. A minus a, it is nothing but 0. So 1 left shift of 0, so 0, 0, 0, 0 and 1. So these 1 and 1 not do any change. It will become the same. 1, 1, 1, 0 and 1. No change. So even though I am adding the operation, it will not no change. Similarly for A also, it is not no change. 1 left shift of 0, 0, 0, 0, 0 and 1. It will no change. So it becomes 0, 1, 0, 1 and 1. Okay. So no change. Similar will be there. So this is now I am setting the bits like in the same bits, like if A is appear in my small is appearing, first bit this bit will be set. If B is appearing, second bit is set. If C is appearing, third bit is set, like this way. Small. So this is the for lowercase, this is the uppercase. See here now it is not lower is not 0. Now lower is not actually 0 right now. So it is representing something. We know we don't need like what is the value of lower, what is the decimal value of this. We don't need of that. Doesn't matter. We need the number. We need the bits only. Okay. So after that we did the common. Common is nothing but lower and upper. So if I do the AND operation, between these two cases, what will happen? This 1 and 1 it will produce 1. This 0 and 1 it will produce 0. This 0 1 it will produce 0. This 1 1 1 represent 1 and this 0 will produce 0. So what will it reproduce? 0 1 1 reproduce 1 and 1 1 reproduce 1. 1 0 reproduce 0, 1 0 reproduce 0, 1 1 reproduce 1 and 1 0 reproduce 1. This is the my common. This is my common. So what is I need? Number of bits, number of bits are set in my result. So number of bits are set what? Two bits are set. Two bits are set. So this is two. So this is my answer. So you can see here in the string only two cases where my two letters are my special letters. Okay, this is all about this approach. This is a bit manipulation technique. So this is how you can also do that. So where it is, how much it is taking the time? It is taking time big of n only, big of n. And bit this thing also takes some time, but I'm considering this at most it may say like if they are in the worst case how what it will be. You can think it is iterating for one case, so it could be big of one as well. Doesn't matter actually. So time complexity is time complexity is nothing but big of n. And space complexity earlier, even though just a constant bit, but we are using some extra array, right? But here it is strictly big of 1. No extra space at all. Okay. Hope you are getting it. And I noticed like my audio is not clear in the previous video, so sorry for that. Use headphones to hear those. If you hear it, if you using headphone, then you will be able to hear properly. Otherwise, the normal laptop speaker on normal speaker will not able to hear. But in headphone, you can hear and understand clearly. Sorry for that. Right now, from this video onwards, I am increasing my audio level. Sorry for the previous videos. Okay. And as always, if you find any mistake in this video, please let me know so that I can rectify. And if you find any useful information on this topic, please also let me know. Then I can also learn. Thank you. Bye bye.